Hello, everyone, and welcome back to the Copernicus Polar Workshop. This is day two, and before diving into the thematic session and discussion planned for today, I would like to give a very brief recap of the very interesting and dense discussion that we had yesterday. Of course, we highlighted the link between the Copernicus program and the support to the policy initiative at European level, in particular to the EU Arctic strategy, where capacity of Copernicus to both monitor the environment and climate and also to support local communities represent an important asset. We then also presented a new initiative that might be very relevant for the audience today. One in particular is the launch of the Copernicus Thematic Hub that will, in the future, provide an easier access to Arctic-related products and data stemming from Copernicus. You will hear more a bit later during today's presentations. We then move to a very dense and relevant discussion on support to monitoring climate change and the environment for the polar region. And here, my take-home message is it's clearly that Copernicus has an important role in providing for this very vast geographical area and, certain sense, remote areas, very important data and information that are useful for monitoring also the changes that are happening very fast in the polar region due to the climate change. And this covers all different dimensions, the ocean, the marine environment, the impact on flora and fauna, and of course, atmosphere and land. It was a very interesting mixed session where we both presented actual capacity of Copernicus services, but we also highlighted and showcased application that use Copernicus data and services to provide added value information. For instance, it comes to my mind the capacity to monitor extreme ice sheet events driven by climate change in Greenland, or monitoring of the ozone, the evolution of the ozone hole over Antarctica. No, but also moving in the less dimension, which are moving far from the physical variables, mapping Arctic phytoplankton, or understanding the behavior of elephant seals at sea. Not to mention the support that Copernicus can provide to the fact that due to climate change, events that before were not the events like permafrost and wildfires that are becoming more and more relevant in the polar region, and the role of Copernicus to support this type of monitoring. The final session of yesterday was on Copernicus for in support of Arctic communities, and this was again a very heterogeneous session where we presented different type of application. For instance, support of remote communities over in Greenland to provide information about the status of sea ice, and that it's a vital information for this local community. Or for instance, the use of Copernicus data in combination with additional data to estimate the potential of hydropower production over Iceland. And we also gave a bit at the look of what EU-funded research and innovation activities providing in terms of output and products for the possible future evolution of the service. It was also important, the feedback that we received from the audience. We understand that there were some hiccup with Slido tool. So for today, again, please try to interact with us as much as you can, using both the Q&A part of Slido and as well the please participate in our polls that will pop up during the discussion. And now it's time to start the presentation for today. Our first speaker is a colleague from the European Commission, Anna Maria Stan. She works at the Directorate General for Research and Innovation, and she's Policy Officer for the Healthy Ocean and Seas Directorate. Please, Anna Maria, the floor is yours. We cannot hear you.
Can you hear me now? No.
Yes, we can hear you now.
Good. Thanks. Sorry for the. There are different mics in the computer. So I was actually thanking you, Attilio, and your colleagues for organizing such a wonderful event on the polar regions. And I'd like to say hello to the other members of the audience. As Attilio said, I work in DG Research and Innovation in the Commission in the Healthy Planet Directorate. And I can only start with highlighting the complementarities between our research program and the Copernicus program, especially in the area where I work, which is linked to the Earth system and its dynamics. I work in the Healthy Seas and Ocean unit, which also encompasses the polar research. And let me also cite some takeaways from yesterday, because I followed some of the sessions. So and linked to research. So the first one is a very basic how space technology and satellite data have changed first our daily lives, but also of course research activities in the earth sciences. But second, it's about the benefits from space technology to our societies, and especially in our case, the Arctic communities, because I work in the Pillar 2 of the Horizon Europe, which always looks at the societal benefits of our research projects that are funded through the program. And a third takeaway is actually a challenge, which is the difficulty to get proper observation for the polar regions because of the remoteness of the tough conditions. And we all know that reliable data about changes in the polar regions are more limited than anywhere else on the planet. And there are vast gaps of in situ data that remain and that make long-term observations challenging. Now, coming back to the research programs, I have, let's say, three main observations that I wanted to share with you, three main updates from our DG to share in this session. The first is about the Horizon Europe program and its predecessor, Horizon 2020, where we have we have around 26 polar research projects that have been funded up to now. They are grouped in an EU polar cluster, and some of them have presented during these two days. And of course, I don't think any of our natural sciences funded projects work without Copernicus, could work without Copernicus. The Pillar 2 of Horizon Europe, where we work, polar research, is supporting the European Green Deal, one of the big political priorities of the Commission, but also the new EU policy for the Arctic and its three priorities. And another novelty that we have under Horizon that is pertinent for polar research and also very much in need of Copernicus data are the missions. We have the mission Restore Our Oceans and also a mission on climate change adaptation. And it's a new way of using research and innovation to finding solutions to some of the greatest challenges of our times. The missions are based on big portfolio of projects, and the polar research projects are also part of this big effort to finding solutions to restoring the ocean or to climate change adaptation. Another point is our cooperation with the European Space Agency in the GRTD, which means mainly coordinating research calls or working, making our research clusters work together with the underlying ideas that ESA has smaller projects already processing part of the data, then the bigger horizon projects could build on the work already done by ESA. And we have a flagship action on polar research, and the main event we organize is the European Polar Science Week. The last edition, last and first, was in 2020, and the next one will happen in 1 year from now in October 2023. And my last point is about international cooperation and polar research, because first of all, polar regions are most of them international regions, and they are very interesting for researchers in general. And also the difficulty to do research in polar regions makes international cooperation actually a necessity. And for this, we have two main tools in the GRTD that we follow. One is the Arctic Science Ministerial, where the Commission is fully part, and our commissioner signed the joint statement last year. We are now looking forward to seeing what will happen with this process. And the second one is the All-Atlantic Ocean Research Alliance, which has a pole-to-pole dimension. And we have reinforced cooperation on ocean research in the North Atlantic, US and Canada, and in the South Atlantic with South Africa, Brazil, Argentina. And this is extended now to polar research. So we are trying to encourage cooperation between our EU researchers and researchers in these countries. So these were my main points: the program and its support to polar research, the cooperation with the European Space Agency, science diplomacy and international cooperation. And I'd like to thank you for your attention and wish everyone a good continuation of the meeting.
Thank you very much, Anna Maria. It's needless to say that Copernicus is an operational program, but its roots, its fundamentals are based on research and science and innovation. And there is a clear, there's been and there will be always a clear connection between the evolution of Copernicus and the research, the program like Horizon Europe. Now we're moving to the keynote speech of today, which will be given by Dr. Samantha Burgess. She's Deputy Director of the Copernicus Climate Change Service, C3S. And within C3S, Dr. Burgess leads the climate monitoring, climate observation, and quality assurance part of the program, among many other aspects. And I want to save time. Please, Samantha, floor is yours.
Thank you so much, Attilio. If I could have the slides, please. It's always challenging to be the second day of a conference with a keynote when there was so much rich discussion on the first day. Next slide, please. But needless to say, I think many people in the audience are very much aware of the crisis that faces our polar regions. And I think none more so give this information than the small multiples with the polar perspective, focusing on the Northern Hemisphere, where we can really see the level of changes in terms of how much warmer the Arctic is than it was, 50 to 70 years ago. And there are numerous reports, and I'm sure others have already mentioned the World Economic Forum Global Risk Report, which shows the top 3 most severe risks on a global scale over the next 10 years, climate, extreme weather, and biodiversity related. So having access to reliable and open data to manage these risks and to ensure resilience of the communities and the ecosystems that are based in these polar areas are critical. Next slide, please. So I wanted to start my presentation with a story, because I think when we're so close to the data, we forget that perspective is everything. And, I myself suffer from this, that I rely on what the scientific data is telling me, rather than how other people perceive that data or don't perceive it because they find graphs challenging or statistics challenging. So I had the incredible fortune to travel to the Arctic in 2017, and this is a glacier front in Greenland. And the photo in 2017 that you can see in the bottom right is the photo that I took from a kayak that day. And we were lucky enough to join a group that had been traveling to the same destination that was the 4th year. So we could compare the photos and look at the changes in approximately the same week every year for the last 4-year period. And the reason why I wanted to include this is because I was at another meeting last week, and there was a journalist there who talked about how she'd traveled to Svalbard and to cover climate change in the Arctic, and spoke to another journalist there who said that they didn't see the change. They saw that it was a beautiful landscape. They enjoyed seeing the polar bears. They enjoyed seeing the rolling green hills because it was summer, but they didn't see the crisis, the climate crisis. And next slide, please. And I think, for scientists who rely on data, but also rely on communicating the impact of this data, is really important to look to stories to enable people to understand the gravity of the changes that our planet is seeing. And luckily, with the Copernicus program, these are 2 images that show a different view, the Sentinel-2 view of 2017, so the same year that I was in the Arctic, and then the lower picture is 2022. So again, looking at these different perspectives really shows us this change that visual representation is so important to support the data. Next slide, please. So I'm sure many in the audience are intimately familiar with the Copernicus climate change servers, but ultimately I'll spend a couple of minutes describing what we do and what some of our key polar products are. So at the center of everything is our climate data store, where we provide free and open access to climate data, where we cover everything from observations, from satellites, from Earth, from the sky, from the sea. We convert that data into usable information that is the raw data, but then applied data products that are available on the CDS, applied applications from that data, and hopefully all of this data is useful for society at large, for decision makers, for businesses, and for everyday citizens. At the moment, we have very close to 150,000 users. The typical download is 100 terabytes per day. And we have over 500,000 requests a day. So this is, in a snapshot, a key example of how much value society and European taxpayers are getting out of C3S and the data that we provide. Next slide, please. And what's important is this context. So not only do we have climate data from the past in terms of observations, in terms of reanalysis, but also of the present. So we have near real-time monitoring, we have seasonal forecasts, and then we also have the seasonal predictions and the climate projections, where we use the same data. We have the same data available as was used in the recent IPCC assessment report, so that people can access data for all different time periods within the climate data store, whether they need to understand how climate was in the past or how it will be in the future. All of the information is available. And ultimately, this is incredibly important to make those choices of what future we would like to have, where we can see the low emission scenario where the reds are a cooler color versus the high emission scenario where ambitious change isn't happening and we will lose more ice in the polar regions and more of these critical ecosystems that are so dependent on climate change. Next slide, please. So observations are very much at the backbone of what C3S provides, and we use the Global Climate Observing System framework for the description of the components of the Earth system. So GCOS has described 54 different climate variables that make up our Earth system. And of those 54, we have approximately 30 available in the climate data store. Many of these are from satellite observations. Some are applied products from reanalysis. And you can see on this slide, the blue colors are the changes that we'll make in the second phase of C3S. We'll be getting new ECV products into our portfolio by the end of this framework period, so by the end of 2027. Next slide, please. In addition to the observations, we have a reanalysis. Many people in the audience will be familiar with ERA 5, and we've already had some presentations yesterday on the Arctic Regional Reanalysis, CARA. So CARA in the first phase of C3S was 2 subdomains, but now that we're in the second phase of Copernicus, we've seen the value add of this product. So we're going for a pan-Arctic reanalysis product. It will still continue to be very high resolution, so 2.5 kilometers. We've improved the surface variables and the data sets used. We use local observations that are assimilated to make sure that we can cover the complexities of the topography. As you can see here, the differences between the animation on the top is the changes between the 10-meter wind speed between ERA 5, which is approximately 30 kilometers resolution, versus CARA, that 2.5 kilometer resolution. And then the 2 lower figures are showing the 2-meter temperature change between the lower resolution ERA 5 on the left and the higher resolution CARA on the right. What's really exciting is it's now a full climate reference period. So we have the over 30 years from 1990, and it's also getting to timely updates as well. So we've released data up until the end of 2021, and timely updates will be coming very soon. More information is available on this website. Next slide, please. And ultimately, getting back to the point of the story at the beginning of this presentation, climate monitoring is really important to show that change. So here is a snapshot of many of the climate variables that we cover within C3S that range from the Arctic to or the polar to the European to the global level, and the implications for the different changes of rates. And you can see the glaciers and the ice sheet changes here. If we go to the next slide, please. This climate monitoring is done with a range of different products and scales. So part of the product is very much based on our regular climate monitoring, which is done on a monthly basis. And we leverage both satellite data, reanalysis, and in situ observations. And the key requirements for these data sets is a combination of climate quality and short latency, so a near real-time update. So we can provide information on the climate events. And here you can see some snapshots of the most recent monthly bulletin that was published last week, showing both the highlights for August as a whole for the globe and for Europe, and then sea ice cover for August, which, when we compare to the year before, it is very different. And I think often this variability of the climate system gets lost in the here and now of extreme events. And August was a classic example where it was anomalously mundane, if you will, for the Arctic, in that sea ice for August was much higher than it has been over the past few years, whereas for the Antarctic it was the inverse. Even though it's midwinter there, it was the second lowest winter level for August in the satellite record. The other type of climate monitoring we do is a annual report, and we've had 5 editions of this annual report where we cover not only the European state of the climate, but we also update those global indicators. And next slide, please. So just wanted to draw your attention to some of the key stories from this year's or last year's State of the Climate report that was published April of this year. Next slide, please. Thank you. And you can see here that we have a summary page for the Arctic, and then we go into the key stories behind this analysis as well. So actually moved on one slide. So in this example, you can see that sea ice concentrations were pretty high in the Russian region of the Arctic, but extremely low in the Greenland Sea. So we talk about the individual weather phenomenon, which relate to these conditions that change the sea ice variability in these different sea basins. And going back to this animation, which I'm delighted to see is working, because it's always a risk when you include animation, it reinforces this story of, the change that we've observed in this environment is extraordinary, but communicating that and showing the huge amounts of data that go into describing those changes are incredibly hard to make sure people can understand this. And what's lovely about this animation from Ed Hawkins is really showing not only the variability, but how much change has occurred over this satellite period. So final slide, please. I'll leave it there, and thank you very much for your attention.
Samantha, thank you very much. Another, I think for the audience, if you are curious, you have questions, please use the Q&A button that you have on your screen. So we will look at your questions, and we will try to respond in written, or we'll use the Q&A session later on during the discussion. Again, this was a very interesting presentation, giving an overview, but not exhaustive, of the capacity of the Copernicus C3S service when it comes also to the polar regions. I invite you, if this triggers your curiosity, to go on the official website to gather more information. And now I think we are already a bit late, so without further ado, I give the floor to my fellow moderator, Laurence Crozier from Mercator Ocean International. Please, Laurence.